Oh, hello guys. Welcome to my YouTube channel, guys. Please make sure that you subscribe, you like, and then you share, and then you comment for anything that you're not going to understand or you don't get it clearly. Okay. For today, I'm going to treat with you paper 2 that was written in September 2023 for Free State prelim or preparatory examinations. Okay. So I'm not going to waste any time. My target here is to do question 1, 2, 3. Okay. Because of the time of recording, I don't want my videos to be very long, so I'm just trying to keep them short. Okay, so I'm just going to treat question 1, 2, 3, and that's all. Okay, so let's jump on to the first question. Okay, question number 1. Miss Mufukeng wants to build a swing for his kids to play. The following is a picture of the swing with measurements. We can see the top bar, we can see the ropes. Okay, let me come here. We can see the top bar, we can see the ropes, crossbar, and then the sidebar. So the sidebar, they are 1, 2, 3, 4, crossbar 1, the top bar 1. Okay. Then now they say convert the length of the crossbar to meters. Okay, when you look at the crossbar, what is the length of the crossbar? Is 72 centimeters. So when you convert 72 centimeters to the meters, we divide here by 100. So which is going to be 0.72 meters. Okay. Then let's go to the next one. They say 2 pieces of rope are used to tie each seat to the top bar. The length of one piece of rope is 1.2 meters. Calculate the total length of rope needed to tie 2 seats to the top bar. So if you look, we need one rope here, the second one, the third one, and the fourth one, because they talk about the 2 seats, not 1 seat. Okay, so what are we going to do? We're going to say 1.2 meters multiplied by 4. So how long will that be? 1.2 multiplied by 4. That means the total length needed there is 4.8 meters. 4.8 meters. Okay, then when we move to the 1.1.3, they say each seat is 35 centimeter long and 15 centimeter wide. Okay, it is cut from a wooden board as follows. So this is how they've cutted this. Okay, now they say determine the minimum length of the board needed if you cut the wooden board on the lines forming the seats, because they're telling you that they're going to buy one board and then they're going to cut it in 2 pieces. Okay, so but what is going to be the total length? But you are given what? The dimensions of a seat, one seat, meaning from here to here is 35 centimeters. So how much is the total length? So we're going to say 35 plus 35, because it's also the same from here to here. So it's going to be 35 plus 35, which is 70 centimeter long. Did they say in which units? No, so we use the centimeters. Or we can say 35 multiplied by 2 seats, because the length of 1 seat is 35. So we're going to say that. Okay, then let's continue. Now, they say measure the length in millimeters of the crossbar on the diagram. So I'm not going to do this one, but I'm just going to tell you how to answer that. Remember, guys, when you write paper number 2, you need to have the ruler. And you need to have the functioning ruler. There's a ruler and there's a functioning ruler. The functioning ruler does not have the gaps. The functioning ruler has clear numbers. Okay, so when you're going to write, you need to make sure that you have that. So you're just going to take your ruler and then you measure from this point to this point in millimeters. Remember, the ruler have centimeters and the millimeters. So you're going to use the millimeters, okay? Right, we leave that one. Then they say, Mr. Mufukeng gives his kids the following choice for painting the swing. For the swing, blue, green, or red. For the two seats, yellow and pink. Write down the number of the color combination the children can choose from. Okay, remember there is the swing there. So we're going to have what? Swing. So we're going to have three colors, okay, which is blue, which is green, which is red. But if you choose blue, you have the choice of the seat. The seat can be yellow or pink. Same here, yellow or pink. Same with red, yellow or pink. So your combination is going to be BY. Combination is going to be BP. Your combination is going to be GY, GP, RY, RP. So how many outcomes do you have? You have 6 outcomes. 6 outcomes. Or the combinations. Then they say the top bar, sidebars, and crossbar will be cut from length of steel. It means that they're going to buy a long steel and they're going to cut from that. Determine the total length of the steel needed for this swing. For us to have the this swing, how much of the steel must we buy? The longest of that steel, how much must we buy? Because we're going to cut one top bar, the crossbar, and the sidebar. Now we only need one. We only need what? One top bar, and then we need 4 sidebars. So what we are going to do is this. Okay, let me underline here. So we're going to have the sidebars. So the sidebar, one sidebar is 1,8, I think. Yeah, 1,8. Then how many sidebars do we need? We need 4. And then the crossbar, we need 2 of them. But what is the total length of one? 0,72 meters. Remember, we've calculated that on the first question. 0,72 meters multiplied by 2. Okay, I'm just going to. Then the top bar that we need is, remember, we only need one top bar. We need we need only one, and then only one is how much? 2,2 meters. So the top bar is 2,2 meters. 2,2 meters. So we're going to add everything. So let's start with the first one then. 1,8 multiplied by 4. The total length is going to be 7,2 meters for the side bars. Then the crossbars, we're going to have 1,44. And then we add everything. 7,2 plus 1,44 plus 2,2. Then the total length must be 10,84 meters. Right, then that is the total length that needs to be bought. Now let's come to the next one. They say after the top bar is cut from 6-meter piece of steel, there is 3,8 of steel left. Calculate how many side bars can be cut from the leftover piece of the steel. Remember, we are left with 3,8 meters. And how much is the length of one side bar? And they want the one of the side bar. So one side bar is 1,8 meters. So let's see. 3,8 divided by 1,8. And then we get 2,11. 2,11. It means we can only cut 2 side bars. Okay. Let's go to 1.2. 1.2, it shows us the 2 times there. We can see clock A and clock B. The following 2 clocks are given. The diameter of clock number B is 28 centimeters. Define the term diameter using the given context. Okay, remember the diameter, you can identify them when you see them, but now let's define them. This is a diameter and this is the radius. But then now let's define. So what is it that you can define? You can define this line. You can say diameter here, but we talk about the clock, is the line from one side of the clock through the center. It must pass the center, né? Through the center to the other side. That is the diameter. But the radius, we're going to say, if we were to explain the radius, I'm just giving an example. We're going to say the radius is the line from the side of the clock to the center of the clock. But then when we talk about the diameter, now it moves from this side to the other side, but it passes what? The center. Okay, the following statements are made regarding clock A and B. Write only the letter of the statement that is true. The time on clock B is 8 minutes to. The time on this clock, we can see that is 8, but then this one is pressing 12. It means that this is this is 6, 7, 8. So this is 8 o'clock. So the statement is out. The time on clock BA is a 12-hour format. Is this one in 12-hour format? No, they have specified here. They say 24 hours. Okay, so this one is out. Number C, clock A is an analog. Is this clock an analog? No, this is a digital. This is the analog. The time on the clock A is in the morning. Yes, if this is in 24 hours and it says 9:45, this is in the morning. That means the correct letter here is number D, because if this was in the afternoon, it was going to be 21. Okay, because it's in the 24-hour format. Number 1, 2, 3. They say Jaco had to be at school at 8 a.m. but only arrived at the time indicated on clock A. Write down the number of minutes that elapsed from when he was supposed to be at school. So when you go to your calculator, there is this sign. If you're using the Casio, you're going to see this sign. You're going to see this sign. If you go using the Sharp, it's going to be DMS. Okay, so you're going to say 8 o'clock minus 9:45. So what do? You press 8 and then you press that sign. It will have 8 like this. It will have these 0 zeros like this, minus 900. I mean 9, you press that, and you press 45, then you press that. So let me do it. 8, then I press it, then I press 0 0, I press it again, then I say minus 9, I press it again, then I say 45, I press it again, and then it gives me 1 hour 45 minutes. 1 hour 45 minutes. But they want your answer in minutes. Okay, so we know that this is 45. 1 hour has how many minutes? 60 minutes. Then we add with the 45 minutes. So that is going to be 105 minutes. Okay, then let's move to the next one. We move to 1.3. So when we move to 1.3, they say Mr. Johnson stays in Johannesburg, but regularly travels to Durban. He uses the following route map to plan his trip to Durban. So you can see the map there. We have the Hillsburg to Mpumalanga, Kruger National. We have the Newcastle. We have Ladysmith, Pietermaritzburg. Okay. Then now they say Explain what a route map is in the context. Explain what a roadmap is in the context of the question. So when you look at the roadmap here, in this context, they talk about Mr. Johnson, okay, who stays in Johannesburg but travels to Durban. So in this context, we're going to say a route map is what? Is the map that shows us the routes between from Johannesburg to Durban. I explain again. The route map shows us the routes from Johannesburg to Durban. Okay, now let's go to number 2. Write down which national roads is the shortest route from Johannesburg to Durban. So you see, when you're using this one, there are no distances here, so you just have to look at the shortest route. So you see from here up until here, but there's another route that you're gonna come and then go this way, come here, come down here. So the shortest route here is going to be N number 3, national route number 3. So this is N3. Then they say Mr. Johnson decided to travel to Durban via Newcastle. Name 2 towns beside Newcastle that he will drive through. Okay, he doesn't want to use what? The N3, but he must pass Newcastle. But don't tell us about the Newcastle. Which 2 cities is he going to pass? Okay, he's coming, he's going to pass here. Oh, he's going to pass this one. Again, Standerton, and then the Volksrast, and then also remember, it's not going to pass what is that? They are not showing us the point of the Ladysmith. But you see, even if they're showing us here's the Ladysmith, but Ladysmith is not on this road, so he's not going to pass. So the towns that he's going to pass is the Standerton, and then Pietermaritzburg. Oh, I skipped that one there. Pietermaritzburg, and also this one. Okay, let's go to number 4. They say Mr. Johnson wants to travel with the N3 and then the N5 to Cape Town. Determine the province through which he will drive according to this route map. So if you look at N3 and N12, so the province that he will be in, look at this. This is going to be via Free State. So the province there is going to be Free State. Free State. Then now they say determine the probability of finding the R505 on the route map. Write your answer as a percentage. Let's look for the road that says R505. Do we see that road? Let's look for that road. I see R23, 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 R111, R11, R505, R103, 616, 103. So we don't have. So the percentage, the probability as a percentage there is what? 0%. Okay. Then we move to question number 2. They say Mr. January import bar stool that he sells again for a profit. The important bar stool comes in a box with an assembling diagram. Annexure A shows the assembling diagram for one of those chairs. Use the information in Annexure A to answer the questions that follow. Okay. Okay. There we have it. That is Annexure A. We have the A there, we have the seat. B, we have the base. C, we have the pedestal with footrest. Then number D, we have the shock absorber. Number E, we have the screw multiplied by 4. Number F, we have the tool. A1 multiply by 1. Then we have the steps. You put B together with D. It means B and, that is the first step, B and D. You put the base together with the shock absorber. Step number 2, they show us number C, which is the pedestal with the footrest. Number E, then now you use the tool. That means the tool, those tool, that was number F, man. It's number E. Number E, they say we put C, we see the pedestal, and then the number E, we put the screws. It means now we're going to screw the A with C. Then the next step, number 3, we have put C and A together. That means the seat and the pedestal with the footrest. Then now we put the whole combination, we push it down to step number A, where we put the base and the shock absorber. So that now that is number 4, that is the chair. Okay, but let's go to the questions. So now they say use the information in annexure A. Use the information in annexure A to answer the questions that follow. Write down the function of the part labeled F within the context. This one, the tool. Always get this. I always buy these chairs online. So I have the manual there. You'll always find this tool. So this tool, we use it to fasten or to loosen the screws. We don't use it on the base, we don't use it on the seat, we don't use it on the shock, but we only use it to loosen up or to fasten up the screws. Okay, we move. 212. Match each. Okay, let me just write this one. To fasten the screws. Match each of the following description A, B, and C below to step 1 to 3 on the diagram to explain how the assembly to assemble the bar stool. Write only the correct order of letters A to C next to your number. So now let's see this A, which step is it going to be? They say push the seat and the pedestal with the footrest combination onto the shock absorber. So when you look here, they are talking about this step, the way I was just explaining. They say push the seat with pedestal with footrest to the what? To the shock absorber. So that is step number 3. So A is going to be what? Step 3. A, this is what? Step 3. Then let's go to B. B, they say remove the cap from the shock absorber and press the shock absorber into the base. Now we are attaching the base and the shock absorber. So that is step number 1. So number B is step 1 here. Step 1. Then number C, they say fasten the pedestal with the footrest with the screws to the seat. So that is step number 2 there. That is step 2. Okay. They say the shock absorber allows the bar stool to be adjusted upwards or downwards. Give one reason why a bar stool must be adjustable. To allow people with different height. Remember, when you are short, the way I was sitting on the stool is no longer going to be the same as you. If you are short, and then because I'm taller than you, and then that means if I'm tall, I'm going to push the stool to be down. I'm going to adjust the stool to go down. But if you're short, you have to adjust it upwards so that you can sit well on your table. Okay. Right, 2.2. We have another annexure. Okay, let me just zoom in. Okay, here is the annexure. Let's hear what they say. They say Mr. January stays in Kronstadt in the Free State. He travels to Vernagen to sell his bar stool. The map on Annexure B shows the route taken by Mr. January from the Kronstadt to Vernagen. Use the information above and Annexure B to answer the questions that follow. They say name the type of the map in Annexure B. Let's look at that map. Which map is this one? Okay, this map here, we talk about the strip chart map. Okay, and we have the provincial, we have the street, but then this one is the strip chart map. Strip chart map. Okay, then they say calculate the distance from the Kronstadt to Vernagen. Let's go and look at that. When we see Vernagen is not on the N1, but from N1 you have to off ramp, then you take 15 kilometers out. You must drive for 15 kilometers afterward. Okay, there it is. But where is the Kronstadt? The Kronstadt is here, and then the Vernagen is here. So what are we going to do to calculate that distance? We're first going to say, because the distance is from here to here, so we're going to say 317 minus 209 to check the distance in between. 317 minus 209. That is 108. But remember, that is not the real distance. That is only the distance on the N1. But when you see that the Kronstadt is exactly at N1 there. So we must add 15 kilometers here. So what we do now is that we are going to take 108 kilometers plus 15 kilometers. So plus 15, and then that gives us 123 kilometers. That is the distance from Vernagen to Kronstadt there. Okay. Now they say, number 3, Mr. Johnson wants to extend his business to Klersdorp. After visiting Vernagen, he travels to Klersdorp to investigate the possibility of extending his business. Name the road or roads he will use if he drives from his home to Vernagen and then to Klersdorp via Potchefstroom. So he will travel from his home to Vernagen and then Klersdorp. Remember, his home is in Kronstadt, okay? So he'll move from here. He will move from here up until here. Then from here, must go to the Klersdorp via Potchefstroom. It means that he's not going to come back, but he must continue, come this side, pass Potchefstroom, and come to Klersdorp. Okay, so which route will he use? He will use N1 and N12. Let's see. N1 and N12. Mr. January gets a contract to supply bar stool to all the national parks shown on the map. Write down the number of national parks he will supply with the bar stool. Let's go and check. Let's start on top. On top there we have the... So this was somehow a tricky. How do we see the national park? And we are not given the keys here. Okay, so how do we recognize a national park? We're going to see it with the NP. This NP stands for National Park. So this is the Kruger, this is the Pilsbank, whatever there. Then this is 1, this is 2 on top only there. Let's go down here. We don't see NP, but then when we go down, we go down again. This is the game reserve. Then we have the Valbos NP. Then that means this is another national park. So we have 3 national park. So they are 3 national park. Okay, then let's continue down there. Okay, 2.3. So in 2.3 they are saying the following provincial map, this one is a provincial map, also shows Klerksdorp and Potchefstroom. So we are given the type of the scale there, you are given the direction is on top. Right, so what do they want? They say give two difference between the provincial map above and the type of the map in Annexure B. Remember, they can't tell you what type of a map is in Annexure B because you will quickly go there and rub and cancel your answer there. But already I've told you that this is the strip chart, okay? So what is the difference between these two maps? Here are the difference, okay? If you look here, oh, where is it? Oh, it's in the annex to that one. If you look at this map just show you the straight roads there. So when you look at this map, it just show you the straight lines there. Okay, so how can we differentiate between the strip chart and the provincial? Okay, let me say the first one here. Strip charts, the first one is not drawn to scale, whereas the provincial map is drawn to scale. It means that even if you look at the strip chart map, you'll never see the scale there. Okay, again, I think they say 2. So now the first one and the second one. The strip chart map does not have accurate direction. You can't say the direction from Potchefstroom to Klerksdorp is south or what, or southeast or northwest. You understand? Whereas provincial map has accurate direction. Okay, now let's move to the next one. Write down the general direction of Potchefstroom from Klerksdorp. Where is Potchefstroom? Here is Potchefstroom and here is Klerksdorp. They say from where? From Klerksdorp. It means your campus must be drawn at where? At Klerksdorp. Then let's go to, hey, my campus is not straight. Hey, my campus is not straight. Otherwise it's killing me. Okay, better now. Then we join these 2 points. Perfect. Then we can see the north is here, south, west, east. So the direction here is the the north, east. So this is 2, let me write it here, 2.3.2. The direction there is northeast. Okay. Then 2.3.3. Mr. January stated that the real distance between Potchefstroom and Klerksdorp differ between the above map and the map in Annexure B. Okay. What is going to happen here? We are given the scale, but in the annexure, in the map on the annexure, we don't have the scale. We can clearly see the distance from Klerksdorp from Potchefstroom and Klerksdorp, which is 55. Okay, let's see. Number 1, we use what? Okay, strip chart. We can say strip chart distance is straightforward. Okay, the distance there is equal to 55 kilometers. But let's look at the provincial. At the provincial, we can't use that. We must do what? We must use the bar scale that is given here. Okay, because you can't even get that. Okay, so we must use what? The bar scale. So what we're going to do there, we're going to use to take our ruler. Okay, so you take your ruler, you measure the bar scale so that you can get the map distance. So if you measure from here, from the first segment to the last segment, from 0 to 100 here. Okay, I have measured that, and I have got, remember is the map distance is to actual distance. So I have measured in millimeters, and then I got 53 millimeters, okay? 53 millimeters is the map distance, and then the actual distance is what? Is 100 kilometers. Then now what do I have to do? I go to the map again, I take my ruler, I measure the distance from Glasgow to Potchefstroom. I measure again. Now I'm no longer measuring the bar scale, but I measure the distance from Glasgow to Potchefstroom. So when I was measuring there, I got 27 millimeters. This 27 millimeters, remember, is on the map. Do you know how much is 27 millimeters in the actual distance? No, I put a question mark, then I cross multiply. So question mark multiply by 53. That is going to be 53 question mark, which is equals to 100 times 27. 100 times 27, which is equals to 2,700. 2,700. Now, because I'm looking for the question mark, I will divide by 53. I divide by 53, then my question mark is equals to 2,700 divided by 53. It gives me 50,9 kilometers. But remember, when I was looking at the strip chart, it says 55. But then here, you see, it gives me 50,9 kilometers. You see that they are not the same. Right. Let's go to question number 3. So question number 3, we are given Miss Jones is a mother who wants to make a dollhouse for her kids for Christmas. She finds a plan for the following dollhouse on the internet. Annexure C shows the part of the dimensions of the dollhouse. Okay, let's go to Annexure C. Okay, here is Annexure C. Okay, let me zoom it in, okay, so that we can see everything. Yeah, so we have Annexure C. This is the parts of the dollhouse. We have the backboard, side 1, side 2. It has the triangle and a rectangle. It has the sideboard times 2. It has the metal board times 3. It has the roof board times 2. So now what have they given us for this? Side 1 is 39,79. Side 2 is the same. Then the height is 25,576. The width is this one here, which is 30,48. Then we have the length, which is 60,96. But when you go to sideboard, we are given the area of the sideboard. So this is how it was calculated, having the length and the width. And in the middle board, we have them. Okay, so now let's go to the questions. Right. Okay, first question, define the concept area, and they're not saying in this context, so you have to give a general definition of an area. Area is the total space inside an object. Inside an object. Okay, now they say determine the area of the plywood board in meter squared. Round your answer to 2 decimal place. Okay, Now, the plywood board in square meters. Now, when you look on top there, you are told that the whole dollhouse is cut out of the plywood board with the dimension 4 feet by 4 feet by 4 feet. It means that they're going to buy a square plywood board and they're going to cut all those pieces that they want there. So, but they say they want what? The area of that board that they're going to buy. But your answer should be in meters. Then you're given the relationship between the feet and the centimeters. Okay. So what you have to do here is to convert the feet into the centimeters. So how can we do that? So we're going to say 1 feet is equals to 30,48 centimeters. So how many feet do you have? You have 4 feet. Let me remove this one here. It looks like one here. Okay. So do you know how much is the 4 feet in the centimeters? No. Then we cross multiply. So it means our the 4 feet is equals to 30 multiplied by 4. 30,48 multiplied by 4. That means the same 121,92 centimeters. That means 4 feet is the same as 121,92. So that is not our answer. Now we can calculate the area, but the area is going to be in centimeters. So what are we going to do? We can continue and convert the centimeters into the meters. Therefore, we divide this by 100. And how much is the length? So 121,92. Remember, the length is the same as the breadth here. Divided by 100. That gives us 1,2192 meters. So now let's go and calculate the area. Area is equals to length times breadth. So that is going to be 1,2192 meters multiplied by 1,2192. 1,2192 multiplied by 1,2912, and that gives us is that by writing 7? I want to write 1, write 7. That gives us 1,486. So this is approximately 1, did they say round? Yes, round to 2 decimal place. This is 1,49 meter squared. That's your 5 marks there. Okay, then they say use size of the dollhouse on Annex C to calculate the following. Okay, the area of the rectangular part. Okay, we can see the rectangular part, this one. Okay, so how do we calculate the area of a rectangular? They've given us the formulas on top. The area of a rectangle is base height, half of a base times height. Okay, so what are we going to say? Area is equals to half base times height. So how much is our base? So we're going to have 1/2 multiplied by, how much is our base? Our base is the same as the length, 30,48. 30,48 multiplied by, what is that height there? The height is 25, let me write it here, 25,576. 25,576. Yeah, 25,576. So how much is it? So we're going to have 1/2 multiplied by 30,48 is equals to, then multiply by 25,576. 576, and that gives us 935, 46 776 meters squared. Were they in meters or they were in centimeters? So this is the centimeter squared. Let's see. Centimeter squared. Okay. Then now what do we need to calculate? The area of the rectangular part of the bag. I remember now we've calculated the triangle. Now we need to calculate the rectangular now. So we know that the area of a rectangular now is equals to length times breadth. So let's go and calculate it. Okay, so the width is 30. I have used wrong things there. I've used wrong things. So I've used the width instead of the length. I'm just going to cancel a few things there. I'm supposed to use 60,96, not 30. 60. So the answer is going to change, but we're just going to change this one. We're just going to change this one. That is how much multiply by 60, 96. 60, 96. So the final answer, that means it's going to change. So let's see how much is the final answer there. 1/2 multiplied by 60, 96 multiplied by 25, 576. The answer is 779. 779, 55648 centimeter squared. Okay, so let's go back here. The length is 96 multiplied by 30,48. Is it 30,48? Yeah, 30,48. So we multiply the width by the length. So 60,96 multiplied by 30,48. No, my handwriting here is bad. Let me try to write nice things here. 60,96 multiplied by 30,48 is equals to 1,858,0608 centimeter squared. Okay, then we have the last one. The total area in meter squared of all the boards to make the dollhouse. So we need the backboard. Remember, the backboard is made of this. Okay, let me come here. The backboards, remember, when you do the dollhouse, it doesn't need to close off. The child, when they play, the kids, when they play, they need to see the inside. So you can't have the front. You're only going to have the back and the side. So at the back, we already have this. We've calculated the area of this triangle and the area of this rectangle. So of which we only need one board for those two. So the total area, we're going to start by this, is equals to, let me open the bracket to say 1,858,0605 centimeters squared plus the area of that triangle, which is 779, 5 centimeters squared. All right, so we have the back. Okay, so we're going to say plus. Let's see what else do they need. It have been specified here. They need 2 side boards, these 2. They need the middle board, they 3. They need the roof board times 2. So we are given the areas of those, so we're just going to take this and multiply by 2. This area here multiply by 3. This area here multiply by 2. Okay, let me take the first one. The first one is 464,515,2. Okay, how many of them? There are 2. So we're gonna have 464,5152 centimeter squared times 2 close brackets plus open brackets. We go to the next one. The next one is 926,4396. How many are they? 3 of them. So we're gonna have 926,4396 centimeter squared multiplied by 3 plus open brackets. The last, I think, is the last one. Yes, this one. So this one is 1,248. Let me remove this because the 1,000, the one is been hidden here by my drawings. So that is 1,248,4602 multiplied by 2. So it's going to be 1,248,4608 centimeter squared multiplied by 2. So you just take everything the way it is and then you punch it. Make sure that the brackets are visible there. So it's going to be 1,858,0605 plus 779,55664 close brackets plus open brackets 464,5152 multiplied by 2 close brackets plus open brackets 926,4396 multiplied by 3 close brackets plus open brackets again 1,248,4608 multiplied by 2 close brackets. Then how much is it? That is 8851,8877 centimeter squared, but they say they want it in meter squared, therefore you divide here by 10,000. Divide by 10,000 because we are converting the centimeter cubic to the meter cubic. This is 0.88 meter squared. Let's go to question number 3. Mr. Jones also bought a pool for her kids for Christmas. The pool looks as follows. There's a ladder there of getting inside and the outside. Mr. Johnson find the following dimensions for the pool: diameter, the volume of the water when the swimming pool is 90% full. That means they are not going to fill the pool 100%. Note, 0.001 meter cubic is equals to 1 liter. You may use the following formula. So what I see here is that you are not given the height. So it's possible for them to say how much is the height of the pool. Okay, you may use the following formula: the pi r squared multiplied by height. That is the formula of calculating the volume of a cylinder. Mr. Jones also want to buy a ladder for the kids to get into the pool. The ladder should be higher than the height of the pool. Do you have the height of the pool? No. How are you going to compare? She has a ladder of 1.1 meter in mind. Will the ladder be high? Show calculation to verify. So now, you don't have the height, but they want you to compare the height of the pool with the height of this ladder. Now look at this formula here. You have V is a value, R is a value, height is a value. So every time when, how many values are here? So this formula has 3 values. So if you have a formula of 3 values, they will always give you 2 values to calculate the other value. Is that true? Is that what we are given? Yes, I've seen that. We are given the diameter of which we are going to calculate what radius. We are given the capacity of which we can change it into what? Into volume, because now we are given the milliliters, so we need to change them into what? Into the meter cubic. You understand? So what are we going to do there? Let's do it here. Radius, let's calculate radius first. Radius is equals to 3,4 divided by 2 is equals to 3,4 divided by 2 is equals to 1,7. 1,7, that is our radius meter. Okay, then let's now the pool, the height of the pool is, it must be 100%. Okay, so it's not going to be according to the water, it's going to be 100%. But they're telling you that when the water is 90% full, it's going to have 9,090 liters. So let's check how many liters are we going to have when the pool is 100% full. So we're going to multiply here by 100 over 90. If you know the Cremora method or the UK method, you know why we take the 100 on top and the 90 on the bottom. The reason why we put the 100 on top is because we need the 100% out of this 100. This 9,000 represent what? It represents 90%. So when the full is going to be 100% full, it's going to be 10,000. It's going to have 10,100 liters. Okay, so now what are we going to do? We are going to convert the 10,100 liters into the millimeter cubic. Okay, so how are we going to do that? They told us that 0,001 meter cubic is equals to 1 liter. So let's do the cross multiplication. So we're going to put 10,100 here. We put the question mark here. Then we cross multiply. So it's going to be 10,000 multiplied by 0,001. And that gives us 10,1. Our question mark, which is in the millimeter cubic, is going to be 10,1 meter cubic. Okay, now we can see that the volume of that pool is 10,1 meter cubic. But remember, we are given the radius and the volume, but we need to calculate what? The height. So now let me teach you something like this. This is what I like to teach my learners. I'm going to take those values and put them in this triangle. This triangle, this line here means what? Divide. But then this one here means a multiply. So I want to take the whole formula here. So when I look at it here, it's going to give me the same definition. So if you look at the volume, they say pi r squared multiplied by height. It means we must put pi r squared here and we put height here. If we put those, we're going to put v here. So now if we need volume, we just come and hide v. So what else do you see? Pi r squared multiplied by height. But then in this case, we have the volume. What do we need? We need the height. So if we need the height, what must we do? We must hide the height. What do you see? So you're going to say height is equals to volume over pi r squared. So how much is your volume? 10,1 meters squared divided by how much is your pi? 3,142 open brackets. How much is your radius? 1,7 meters, then we close the bracket, squared. So that is equals to 10,1 meter cubic is equals to 3,142 multiplied by what is 1,7 to the power 2. 1,7 to the power 2. That is equals to 2,89 meter squared. So how much is it going to be? Oh, it's taking long, 10,1 meter cubic divided by 3,142 multiplied by 2,89, and that gives us 9,08038 and meter squared. Then let's see, 10,1. Then our height is equals to 10,1 divided by 9,08038, and that gives us 1,11 meter. So now let's go back again. Will the ladder be high enough? The question is no. The ladder won't be enough because the height of the pool is 1,1, but she has in mind the height of 1,1. Okay. Give a reason why the ladder below must be placed over the edge of the pool. Why? Because we need is for kids to go in and out of the pool. So this brings us to the end of this paper for first aid. So I wish you luck, guys, on all your examinations. So please make sure that you subscribe, and then you share, you like, and then you comment whatever that you don't understand.